Hello, everyone. We are Team Cognify, and today we're tackling a critical issue faced by heavy commercial vehicles. Some of the issues that this system will be able to monitor and alert its users include underinflation, overinflation, and imbalanced tire wear. While these problems are known to worsen fuel consumption, they also increase the probability of occurrence of accidents to a great extent. However, the currently used tire monitoring systems are not effective because they are vulnerable and require constant maintenance. Our innovation solves all these challenges by using ultrasonic sensors and AI, which gives a better, safer, and long-lasting tire monitoring system. Heavy commercial vehicle is often associated with tire problems such as underinflation, overinflation, and irregular wear of tires, which may sometimes cause accidents and higher fuel consumption. TPMS of the past has certain disadvantages. They can be damaged, and they need to be recharged constantly. Such challenges render existing solutions unsuitable for the prolonged period of use. The problem that our solution addresses is the lack of reliable methods of tire quality monitoring, especially the ones integrated, externally mounted, ultrasonic sensors. Such working sensors integrated with artificial intelligence will determine tire pressure and temperature significantly and continuously without disadvantages compared to internal systems. The ultrasonic waves penetrate through the rubber tire and bounce off the metal wheel. In this way, the system is able to work out the tire pressure by noting the time it took for the waves to get back. This method minimizes the chances of damage on the system, hence enhancing chances of a longer lifespan. For tire pressure and temperature, our system uses ultrasonic sensors that calculates the back echo sound time from the metal wheel shell. The gathered data is then fed to a machine learning model through a vehicle's dashboard app, where algorithms such as random forest is used in analysis. This data is presented in an easy-to-use format through an app interface which would have been designed using Java and would show real-time statistics and suggestions. BLE technology is employed in the transmission of data from the sensor to the dashboard, thus allowing constant and real-time analysis of the tire conditions with maximum efficiency with minimal power consumption. This integration helps the user to receive alerts at the right time and make the operational safety of the vehicle possible. In this description, I also showed that our solution is technically as well as economically viable. The sensors are of enhanced ultrasonic technology, which supports real-time measurement, and BLE for power-efficient signal transfer. The sensors are designed to be placed at strategic positions with an aim of reducing the effect of noise on the data collected to enable the system to be used on different types of vehicles. From the economical perspective, it can be explained by the fact that the price for the sensors and BLE modules is rather low. The cut in the cost of fixing accidents and the losses occasioned by their vehicles being off the road provide a strong rationale for the investment. Thus, it may suit a fleet owner or just ordinary users. The use of our tire monitoring system will go a long way in minimizing the number of accidents that arise from faulty tires, thereby minimizing on extra expenses, such as repair costs and legal lawsuits due to accidents. Data retrieved in real time enables early intervention, thus increasing the life of the tires and reducing fuel requirements. Reduced operational cost, better safety of drivers, and better performance of the vehicle will be of great benefits to fleet management service providers and the commercial vehicle operators. Also, AI integration also allows for predictive maintenance and hence improving the reliability and functionality of vehicle operations, thus making transport more efficient and sustainable solution to the existing problems. Thank you for your time and attention. We're eager to bring our solution to life, enhancing safety and efficiency for heavy commercial vehicles. This prototype uses basic ultrasonic sensors to measure the tire pressure and tire temperature, mimicking the setup that could be applied in real vehicles. Let's start with the hardware setup. Our system uses the SIH2024 ultrasonic sensor, which is mounted to face the tire. The sensor measures the distance, which we then calibrate to estimate tire pressure. Our calculations derive the corresponding internal tire temperature based on pressure data. The heart of the system is the Raspberry Pi Pico W microcontroller. It processes the data collected from the sensors, including measuring, calibrating, and tuning the values to get accurate tire pressure and temperature readings. This processed data is then displayed on a 16 by 2 LCD display, simulating a vehicle dashboard, allowing drivers to monitor tire health in real time. The collected data, such as tire pressure and temperature, is also sent to the Firebase real-time database. From here, our AI model, which uses a random forest algorithm, accesses this data for further analysis. This model refines the data, making additional calibrations and tuning to provide even more accurate predictions of tire conditions. This approach leverages machine learning to improve data accuracy over time, adapting to various conditions and enhancing the reliability of our measurements. Once the AI model processes the data, the final refined values are sent back to Firebase and displayed on the vehicle dashboard. This prototype effectively showcases the core functionality of our smart tire monitoring system. Although we're currently using basic sensors for demonstration, the concept scales up with more advanced sensors for real-world applications. The system can be integrated into modern vehicles